Today, we will learn the numerical derivatives in MATLAB. So, numerical differentiation. Usually, we use this 5-point formula. F prime xi. So, this is the first order derivative at point xi. So, equals 3f(xi minus 4) minus 16 f(xi minus 3) plus 36 f(xi minus 2) minus 48 f(xi minus 1) plus 25 xi over 12h. H is the step size. Usually it's a small number. So this means if we need to get the first order derivative at the point xi, we need to preview the point numbers and also the current point, the function number. So totally we need 5 points values to get the current points derivative, first order derivative. And for this one, this is important. So for numerical differentiation can apply phi error. This is because this formula. So just for example, if there's an error, okay. So just for example, if this function has some error, just plus error here, this error could be a small number, but this error divided by a small number. So we know for the h could be, usually we use 0.01, 0.02, even small numbers, right? Then a small number, just for example, 0.1, just for example, error is 0.1. Then divided by 0.01, so we know this equals 100. So the error, small error becomes big. Maybe the error can over greater than the function numbers. So this is the disadvantage for numerical differentiation. Okay, so let's keep going. Then for this example, so we will use several different methods to calculate first order derivatives. And so for compare the results among the different methods, so we need to use this the term MSE, mean square error, to compare the algorithm. Which one is better, which one is worse. So MSE equals the xi caret. So this one is the spherical number. Then minus xi, so this is the calculated number. Then their difference, then square. So this means even the difference is the negative, after square becomes a positive number. Then sum these numbers, the difference square, difference together, then divided by n. So n is the points numbers. Yeah. So this is MSE, mean square error. Okay, so now we have these files. I already opened this file in online MATLAB. So go to MATLAB now. It's done. Okay. It's opening another one. Okay. Oh, I already opened it. So numerical derivative 5 points. Okay. So clear all, close all, COC. I use a lot in my files. Okay. Then load el-center.mat. So this is the MATLAB that file. So let me copy this. Then run this in command window. So at the beginning, so let me clear everything. Okay, let me show workspace. So you can see workspace now is empty. So load this file. I already put the file here. So you need to put the data file in the current MATLAB source file folder. Okay, they should be in the same folder. Then we have this one. N is the points number. Then A for acceleration. H step size, so 0.02 second. I, so this is also is the number, this is index number. This Y, so this is the time vector. V for velocity, X for displacement. This one actually is for the former one, is the el-center, the earthquake data. We get, this is the original data. We know this is the acceleration. Integrating once, get the velocity. Integrating again from the velocity, we get the displacement. Then save this, the variables in a file. So it's this file. Okay, el-center MATLAB. Okay, so let's keep going. So load this one. So we don't need the length of the vector because we already have this in workspace, right? And then for V1, so create a 0 vector. Okay, so the same size with the original, the acceleration vector. So zeros n comma 1. Then V2, so that's for 2-point method. So very simple one. So just actually this we could think about this is the delta x. Okay, so then no, sorry. Okay, so f prime xi so equals f xi minus f xi minus 1 then over delta x. So we can just use xi minus x minus 1. So actually this is the delta x. Okay. So that's the 2-point. 2-point method is very rough. Okay. So for velocity, now we use the 5-point method first. So since the 5-point method, we need to know the first 5 or the 5 clear the numbers. Okay. So at the beginning, so at the first 5 points, we cannot use the 5-point method. So we use the 2-point method to get the derivative. Okay. So for I equals 2 to 5. Then V1 I equals xi minus xi minus 1 over divided by h step size. So first 5, so we just use 2-point method. Then from the 6th point onto the end point, so now we can use the 5-point method. So use this for loop. So this is the same as the we use the formula in the handout. Okay. So we add 1. So after these 2 for loops, so we get the V1 the first order derivative from displacement, right? Use the 5-point method. Then 2-point method. So we just use this for loop I equals 2 to 1. 2 to n, sorry, v2I equals xi minus 1 over h. Okay, like I said before. So this is a very rough one. Then for MSE, I also use the two methods to get MSE. First one, so we use a for loop. I said before, for loop is time consumed in the MATLAB, but for loop, when we use for loop, you can get the idea clear. Okay, understand the idea clear. So SSE for V1 equals 0. SS2 for the V2. Okay, then use the for loop. For I equals I to n, then E1 E for error. E1 equals V1I minus Vi, then dot caret H. So we need to use dot caret. Okay. Then SE equals XE1 plus E1. So you can see that's the velocity from the 5-point method minus the velocity in the file, in the data file. And so V actually is from this data file. Okay. So this is for V1. Similarly, we use this one. So E2 equals V2I minus Vi dot caret 2. Okay, so this is for V2 for 2-point method. So SE2 equals SE2 plus E2. Then after this for loop, we get the sum. The mean square error means divided by n, right? Just remember this one. So sum use the for loop, then divided by n. So this is the this is the mean square error. So MSE1 equals SE1 divided by n. I didn't use the semicolon here, so this result will show in the command window. Similarly, MSE2 equals SE2 divided by n. Also show the result in command window. Then this is use the for loop, get MSE1 and MSE2. Actually, in MATLAB, so we can use a function get MSE mean square error directly. So MSE12, so the second method for MSE1 equals sum V1 minus V2. Just remember V1, V2 are vectors. So when do this, the subtraction, the result still is a vector. Then for the caret, so the square, we need to use dot caret 2. So this means every element in this vector now be squared. Okay, not the vector be squared. The whole vector cannot be squared, right? So use dot caret. So every element in the vector get squared. Then sum, just sum all the results, then divided by n. So we know this is also the mean square error. MSE22 similarly just V2 minus V1 dot caret 2, then sum, then divided by n. So these two methods, so we use different the method get a mean square error. So we know their results should be the same or close. Okay. Then we use subplot. So 2, 1, 2, 1, 2. So we know first two numbers. So this is 2 by 1. So just the 2 rows, 1 column. So just the 2 sub-figure, 1 on the top, the other in the bottom. The first one, so this is the top sub-figure. Plot t by x B. So we know this is for displacement. Describe the time vector. B for blue. Hold on, grid on. So actually, this one we don't need the hold on. Okay. Just this one figure here. Okay. Title: essential displacement. Font size 16. X label times font size 16. Y label displacement m meter. Font size 16. Set GCA font size 14. We used before. So this is for displacement. Then in the bottom, so subplot 2, 1, 2. Plot T-spine B for velocity, B for blue. So this is original velocity in the data file. Hold on, read on, plot T-spine V1, R for the graph. V1 5-point method. Since hold on, so the third curve, plot T-spine V2 2-point, then C, state for psi. Then the next one, so legend, original, so original for the first curve, 5 points for the second curve, 2 points for the third curve. Okay. Then title, the essential velocity, font size 16, X label, time the same, Y label, velocity, meter per second, font size 16, set GCR, font size 14, the same as before. So now we can run this one. Okay. So top is the displacement. The bottom, so totally there are 3 curves inside. Original blue, 5 points red, 2 points is the sign, so you can see almost the same. Right? Actually, we can zoom in to get it clear. We can also go here. There are a lot of people here. Okay, we can zoom in again. So blue is original. Red is the 5 points. Sign is the 2 points. So you can see the red curve close to the blue curve, then the sign. Right. So this from here we can also know 5 points is better than 2-point method. Then the next one, so we go to the command window. So MSE1, this is for the 5 point. So error, that's the 0.004. Then MSE2, this is the 2-point method, 0.0138. So this almost 3 times greater than MSE1. So 2 point is not as good as the 5-point method. Then this one, so we use the MATLAB, the sum function get the results the same as the for loop. Okay, so this is the example. Then go back to the handout. Then for the homework, so you need to finish this example first, then finish the homework question. So get the derivative of x1 equals sine 2x on the 0, 10. Okay, from 0 to 10. With the 5-point method. Here you just need to use 5-point method. Step size is 0.01. Plot 2 functions in one figure window with subplot function, the same as the example. x1 at the top and the derivative function is in the bottom. And for here, so you need to know this. For the sine function, so x1 equals sine 2x, right? Then it's the first order derivative, x1 prime, so actually equals 2 cosine 2x, x prime, so actually it's dx1 by dx. Right? So you are the numerical result, the derivative should be close to this function. So you can use this function, check your result. Okay, so that's for this week.